Okay, thank you. I want to first thank the organizers for this opportunity to speak. Today I want to share something about SMS-algebras. I want to start with abelian categories and triangular categories. We know that there are canonical ways to construct triangular categories from abelian categories. For example, first of all, the homotopy categories, the derived categories, and also singularity categories, and for some, we even have the cluster categories. But the other direction is not so easy. If you have triangular category, how can we get abelian categories? For example, if you have the derived category of an abelian category A, how can we recover A? That's a highly non-trivial question. In the literature, there are two methods. For simplicity, I assume T to be a field, and T, a triangular category shift functor is sigma. The first result was due to Billions and Burst and Berlin. We know if we have a T structure, then the heart is an abelian category. So we can recover for example, from the derived category, we can recover the original abelian category. And of course, much more like the previous shifts, we can recover from T structures. The second result is from cluster tilting theory. If we have a nice rigid subcategory, then we can consider the category itself and its shifted copy. And we take essentially the extension closure, and then we factor out the morphism factoring through the shifted copy. Then this is an abelian category. And it turns out to be the category of finitely presented functors over this given category. This result has played a very important role in the categorification of cluster algebras. And recently, there's a new method due to Peter Jørgensen and Yama and Jin. So we fix an integer w greater than or equal to 2, and this triangular category is assumed to be homofinite and Kroll-Schmidt. Then we can consider particular collection of objects. They are called W simple-model system. Three conditions. First condition is orthogonality condition. Different objects, they have nomorphisms, and the endomorphism is a skew field. So they are like simple modules. The second is vanishing of negative extensions. So in this interval from W minus W plus 1 to minus 1, there are no extensions in this interval, of degree in this interval. And the third condition is a generating condition. So here, this bracket means extension closure. So we take another copy, then another copy. So they are all together W copies, and they generate the whole category. So such a collection is called the W simple-model collection. So now we are given a W simple-model system. So now we are given such a system, and the remarkable result of Peter tells us that the extended closure is an abelian category, and moreover, is actually the module category over some finite-dimensional algebra. So there are some finite-dimensional algebra here. So in general, this result is due to Jørgensen, Peter Jørgensen, and for W greater than or equal to 3 is also another method is by Yama and Jin in a more general setting. Of course, now we are interested in such algebras, which algebras A can occur here as such an extension closure, especially for some nice triangulated categories like negative cluster categories. So now we have a cyclic quiver. Then there is the minus W cluster category. So it's an orbital category of the bounded derived category by this autoequivalence or composed with the W plus first shift, parallel shift. Then this orbital category is the minus W cluster category. And this is minus W clavier triangulated. It's a triangulated category. And in this category, there is a standard simple modular system, namely the simple modules. The QQ simple modules, they form a W simple modular system. And moreover, if we consider the extended chlorine, it's exactly the module category over QQ. So we are interested which algebras may occur as such extended chlorine. Especially the most interesting case is W equal to 2. So now I assume W equal to 2. Then we consider the minus 2 cluster category, and there is a standard 2 simple modular system, and there are much more. And we take every 2 simple modular system, and we know that its extended chlorine is the module category over some finite-dimensional algebra A, and we call such algebra A an SMS algebra. SMS refers to simple modular system. And if anyone has any nice suggestion, please tell me. So now we call it SMS algebra. Then, of course, this Park algebra itself is a typical example, SMS algebra. And then naturally we ask for more examples and properties and even a classification. So such algebras, in some sense, they are due to cluster-tilted algebras. And we don't yet have much progress. Here I want to present 2 results. The first is a general result. If we have a tilting complex in the derived category, we assume its cohomologies are concentrated in degrees 0 and -1. Then the endomorphism algebra is an SMS algebra. So this is a class of examples. And a second example is, maybe I speak a little bit about the proof. So this is a tilting complex. So there are simple modules, like simple modules over this endomorphism algebra in the derived category. And this, if you put this collection of simple modules to the -2 cluster category, this is a 2 simple modular system. And the extended chlorine of these simple modules in the derived category and in the -2 cluster category, they are the same. That's the idea of the proof. And then finally, in type A, we have a complete classification, which algebras are SMS algebras of type A. So they are exactly the connected gentle algebras without cycles. Also the algebra with a derived equivalence, which are piecewise hereditary of type A. And that's all I want to share. Thank you very much for your attention.